Lesson 2.2 is on solving one-step equations. In this video, you will learn to solve equations by using addition and subtraction, and solve equations by using multiplication and division. Your vocabulary for this section include solve an equation and equivalent equations. Okay, so first thing we need to look at is the addition property of equality. This property says that if an equation is true and the same number is added to each side of the equation, the resulting equivalent equation is also true. So if we want to use that with symbols, it's for all real numbers a, b, and c. If a equals b, then a plus c equals b plus c. So if I have two things that are equal to each other and I add the same thing to each side of it, they still remain equal. So here, if I add 3 to both of these, 14 plus 3 on this side and 14 plus 3 on this side, I get 17 equals 17. So they remain equal. I didn't change the balance. If you think about like a scale, you know, if you got like a, whatever, I'm really bad at drawing, but if you have a scale and if you add the same amount to this side and the same amount to this side, it will remain balanced. Okay? All right. Same thing, this is just another way of writing it. So you have negative 3 plus 9, you get 6 and 6. So rather than doing it in a single line, you can do it in like a stack. Okay, so using this idea, we want to use that to solve equations. So we want to solve h minus 12 equals negative 27 and then check our solution. So basically, when it says solve, we want to get whatever variable is there by itself. In this case, it's h. We want to get h by itself, which means what I want to get rid of is this minus 12. So to get rid of it, or to get h by itself, I want to think of that as having plus 0, or I just have 0 over there, so it's just h. So I want to say, what can I do to negative 12 so that I'll get to 0? And I can do positive 12. But remember, if I do something on one side of the equation, I have to do it to the other side as well. So I add 12 to both sides. And here, a negative 12 and a positive 12, like we said, is 0. So I just get h. And over here, negative 27 plus 12, I get negative 15. Okay? And then the second part, it says just check your solution. So we want to just put into our original equation, h minus 12 equals negative 27. I want to put in my answer of negative 15 for h and see that I actually get negative 27. And negative 15 minus 12 is negative 27, so I get negative 27 equals negative 27. We're good. So I can say h for sure is negative 15. Okay, you guys do this. If an equation is true and the same number is subtracted from each side of the equation, the resulting equivalent equation is also true. So if we subtract the same number from both sides, it keeps a balance and it keeps it equal to each other. So in this example, they subtracted 17 from both of them, from both of 8 to 7, and you get 70 on both sides. So it remains equal from the start to the finish if you're doing the same operation to both sides of the equation. Okay, so in this case, I want to solve for c, which means I want to get c by itself, which means I want to get rid of everything else that is attached to c. In this case, the plus 102. So I'm asking myself, how can I get 102 to be 0? And I'm going to do the opposite operation. I'm going to subtract it. I'm going to do minus 102. So positive 102 and a negative 102 makes 0. But like we said, anytime you do one thing to one side of the equation, you also have to do the same thing to the other side. So I'm also going to do minus 102 over here. So here they cancel, and I get c. And on the other side, I have 36 minus 102, and I get negative 66. So here I get c equals negative 66, and then we want to check it and make sure it works. So I'm putting in negative 66 plus 102, and I want to see if that equals 36. So negative 66 plus 102 comes out to be 36 equals 36, and we're good. So my answer is negative 66. Okay, we can do the same concepts with multiplication and division. So I can multiply two sides of an equal equation and they would still remain equal. So for example here, if I have x equals 5 and I multiply both sides by 3, I get 3x equals 5 and that's still the same. They're still equal. So that works. And I can do the same thing with division. So if I have x equals negative 20 and I decide I want to divide both sides by 5, I get x over 5 equals negative 20 over 5 or negative 4. So that still works. So these properties say that as long as you're doing the same thing to both sides of the equation with multiplication, addition, subtraction, and division, then it's okay. So here, if I want to solve this, first thing I want to do is get this mixed number, negative 1 and 3/8, into a whole, an improper fraction because it's easier to work with. So if you guys remember anything about improper fractions, negative 1 and 3/8, I do 8 times 1 is 8 plus 3 is 11. So I get negative 11 and I keep the denominator over 8. Okay, so I'm going to replace this as negative 11 over 8. So I'm going to say negative 11 over 8 times k equals 2/3. Okay, now when I have fractions, the easiest way to get rid of the thing in front of the k, remember this is like multiplying, right? There's an invisible dot there. You can imagine this being multiplied. So the opposite of multiplication is division. And if I want to divide, if I want to do divided by negative 11 over 8, remember dividing by a fraction is the same thing as multiplying by its reciprocal. So I can think of multiplying both sides of the equation by negative 8 over 11. So if I do that, negative 8 over 11 to both sides of the equation, I'm just going to simplify these. So now when I multiply these together, those 11s cancel each other out and those negative 8s cancel each other out. So I end up getting 1 or just k. 1k or just k. And over here, I'm going to multiply my numerators. 2 times negative 8 is negative 16. And my denominator is 3 times 11 is 33. So I get at the end, k is equal to negative 16 over 33. And that's your final answer. For part B, here again I have multiplication times this b. So if I want to get b by itself, the opposite of multiplying by a negative 15, I want to get rid of it. I can divide both sides of the equation by negative 15. So remember, I have to do both sides in order to keep it equal. So negative 15 over negative 15, they cancel and I get b. And over here, negative 75 divided by negative 15 is 5. So b equals 5 is your answer for 3b. Okay, example 4. Ricardo is driving 780 miles to Memphis. He drove about 3/5 of the distance on the first day. How many miles did Ricardo drive? Okay, so we're going to say that the whole distance that he needs to go is d. And he drove 3/5 of it on the first day. So 3/5 of, remember, of, that keyword there means that's multiplication. Okay? And we want to know how many miles he drove. So they say the distance that he's driving is 780. So we're doing 3/5 of 780 to figure out how far he went. So we're going to simplify, we can multiply these by thinking of this as over 1, and we can do 3 times 780 and then divide by 5. So 3 times 780 is 2,340 divided by 5. And when I divide that by 5, I get 468. So we can say he drove 468 miles of the whole 780 miles to Memphis. Okay. And that's the end of lesson 2.2.